Shall we start? So, welcome everyone. I'm really happy that you are here, and I hope I can tell you some nice words about the batteryless IoT. I can talk about it hours and hours. I don't know which finger I should bite off, but I will try to make it short and fit into this 15 minutes. Just a very quick introduction. My name is Zoltán, and I'm coming from company Endrich, which is a German distribution company for components. And like 5 years ago, during the COVID time, when me and my team couldn't go to visit customers, we decided to play a little bit around and make IoT computers. And that's where all the story started. And we are trying to do more and more advanced solutions on IoT. What I'm going to talk about today, you have to imagine a network of sensors that are forming a large, very robust, huge area covered sensor network, which is so low power that it can even be running without batteries, harvesting energy from the visual light and using supercapacitors that are storing the energy that during the night we also can get our data. And these kind of technologies which we use here are really leading technologies on the edge of not the mainstream. And those technologies, like for instance the Danish NeoMesh technology, or the recent version when NeoMesh is above LoRa modulation, offer us possibilities to really run low power network nodes which can use harvested energy. A little bit before going into this batteryless world of sensors, I like to talk about technologies in a way how we come to this conclusion that the best to use a mesh network for collecting environmental data. Of course, like everyone else, we started also with a point-to-point sensor. So we made the sensors having an own internet connection. That's what today guys here are doing with LoRaWAN, for instance, that they give a point where the sensor directly can send his data to the internet. What we do, we want to be global. What we did in the beginning, we used a kind of cellular technology, narrowband IoT or CATM, sometimes even LTE, just to go directly to the cloud. But very quickly, you can see that although we're using very low cost solutions, we use like prepaid SIM cards where the telecommunication cost is only $10 for 10 years using like 500 MB data. Still, there are considerations, not only technical but also economical, that it's better to use a kind of distributed network of sensors where there is no telecommunication cost because the sensors are communicating towards each other locally. Of course, these sensors have to just overcome a few 10 meters or few 100 meters. Therefore, they don't need too much energy because in the previous solution, there's an energy constraint for cellular technology. You need to have energy. So you either had to have big batteries or you had to have line power. With this kind of technology, when you have these distributed sensors, very low power, you probably don't need at all battery, at all mains power. You can go with small batteries for years. And of course, there should be one device in the network, which is the gateway device that takes care of the data coming to the cloud. And I just want to talk a little bit about the technology which makes it possible all. And this is the NeoMesh technology. Thomas from NeoCortex is also sitting here in the audience. He will be around our booth to tell about this technology, which makes all possible for us. That's a sub-gigahertz technology which penetrates through walls. In this industrial environment, it works very well, very low power, very smart, time synchronized protocol to deliver the data. It's not only secured by means of data security, but also it's like cable-like strong. So it can be used instead of wired network easily, and you can employ a much higher number of nodes into this network than with the other mesh technologies, as well as you can have a complete outer route way of getting the data from point one to the endpoint, everything is figured out by the protocol itself. So it's really a nice technology, and as we agreed, I think earlier, a trustful IoT solution is a combination of a kind of high operational reliability, like the cable-like reliability, which is offered by the acknowledged protocol. It can be set, this protocol, to be acknowledging between the start point and the end point, and also from node to node. There are also a handshake in between. And the data security part, which is the other segment of the trustful IoT solution, is of course the data is secured in this network. But of course, you should listen to Thomas tomorrow. I think tomorrow you will have your presentation. We'll explain a lot more about it. So because this is a very low power protocol, we decided to make sensors which do not have battery at all. Because you can imagine use cases when, for instance, you apply sensors on the top of, on the roof of a manufacturing hall, when replacing battery would be impossible, or it would be very expensive. So in these cases, we can use the fact that these neo-mesh nodes are requiring low power, so we can use them with harvested power. So in case of a solution, you can see we have just a simple board, which I can also show you here later, which is building into the network, which has energy harvesting IC from EPs, and some kind of PV cell. We are using the PV cell from Dracula technology. Also, the guys are here showing you their solution, the layer technology. So what we do is we are harvesting the energy, and if there's enough energy also to charge the battery, or to charge the supercapacitor, then we charge the supercapacitor, and during the night we are powering the device from the supercapacitor and not from the harvested light. So there's the block diagram of such a sensor node, but sometimes it's just not enough. Of course, these are the technologies that we use on board. So that's the Dracula technology, this layer technology of organic indoor PV panels. And there's another technology which we use. It's an organic material-based supercapacitor. This is from a company, Lignia. This is a Swedish company. They are making a very thin supercap, which is offering energy during the night. Sometimes, however, that's not enough. I mean, the coverage is not enough, because either you have a very huge network like you see here to cover with our sensor, but sometimes it's just simply too many sensor nodes are required to cover an area, or the area is too large, or you have to measure too many points. So in this case, what we have done is employing another technology, which is making possible to extend this network, to have it a little wider, to make the distance between the points of the mesh network longer. And in this case, we are employing the neo-mesh, but not over conventional FSK, but over LoRa. So with the LoRa-based neo-mesh, we can reach a much higher distance. We can cover a higher area. And there's a company here also on the Things conference called Ambient from Italy. They came out with this modem, which NeoCortec has applied their stack. So there is a modem here which offers a neo-mesh over LoRa modulation. Therefore, you can go very far away with the sensors, like a kilometer distance from each other, so you can cover a large area. The Ambient model looks like this. I don't want to talk too much about it, because tomorrow Fabio, the CEO of Ambient, is going to have here a workshop where he can show for all of you guys the technology. By the way, on our booth, we are on B29. We can show everything live, and you can see all these products working, and you can have answers to your questions also from us, from all of us. So The thing that we did with the LoRa mesh, we also built into sensors. So you see this sensor, which you see on the screen. This has an employed different kind of supercapacitor. With this supercapacitor, which is a 50 farad supercapacitor, we can send like 1,300 messages during the night. So of course we can go over several days even without sunlight or without artificial light. The rest of the operation is exactly the same as with the previous one. What is also very important, and we learned the lesson, that what kind of antenna you are using. So for this one, we partnered with a company called QuarterWave, and they are very good in this black magic of antenna technology. So we developed together with them an antenna which is so-called a €0 antenna, because there is no cost for this antenna. This is embedded onto the PCB. But it's a very sensitive antenna, and as you see, we achieved with our helical antenna, if somebody remembers the first picture, we had a very simple helical antenna, which is just something to buy on the market. We have like 10 times higher sensitivity. So we can extend the range by a factor of 2 or 3 just by using an embedded antenna. So that's also thanks to cooperation, and we believe in cooperation. So you see, we are integrating a lot of technology into products, but using the knowledge of European leaders of the technology. A little bit of the application, because probably you guys have the question, what can it be used for? And our time is flying, so I really just want to go through quickly on the application examples. All are real applications that we do. So one of the things especially for LoRa mesh is the forestry. When you want to employ a large mesh network in a forest in order to measure soil moisture or water level, groundwater level, then you need this kind of sensor connectivity principles, like for instance nano mesh over the LoRa. And the other one is the live stock tracking. So when you think about a tribe of cows, not in Europe, when we have a couple of hundred bees, but probably in Latin America, when you have 5,000 cows in a tribe, you can imagine that it is a big thing. And with this kind of mesh networks, those moving animals can also be detected if they are part of the network. So if you have a gateway, let's say, for the place where they come to drink, we can check whether one of the cow is existing in the tribe and is not lost somewhere in space. So we can also that one. One of our major areas is refrigeration. We do a lot of refrigerators with sensors, and something new what happens recently. I was in Brazil last week, and we employed this kind of sensor technology in vertical farms where you have like 200 square meters and you can grow 5 tons of salads in that. You have a lot of lighting fixtures there. You have to check the humidity, all the circumstances. The mesh technology and the mesh sensors like nano mesh technology is a perfect fit for such kind of thing. And the last few things, of course, you can use mesh, Leo mesh, the LoRa version or the FSK version in offices, in medical, in hotels or in warehouses. Warehouses is a special usage because usually in warehouses it's not easy to deploy such kind of mesh networks. But if you use the one without battery, you can imagine once you deploy it, you never have to touch it. There will be an operation 24/7. So these are the use cases when we think this technology could be the best use, and we would like really to invite you for this journey with us. Visit us on our booth. We show you. We can also give you a book. We wrote a book about all these technologies, how to employ IoT into a real world, and we are happy to give you a few copies still have. If not, we can offer you a digital version. And thank you very much for your time and that you shared with me the room. Thank you very much.